All right, well, I think we're going to get started here. We're 5 minutes after. I'm going to keep schedule with everybody else. We're going to give the presentation on flexible feeding, and we're with Asyril. So by we're, I mean my name's Josh Teslow, and this is my colleague Connor Hudalla. And I'll start off the presentation. I'll pass it over to him about halfway through. So, who is Asyril? We are the experts in intelligent, flexible feeding systems for the automation industry. Our solutions have enabled both small and large businesses to gain a competitive advantage through throughput and profit from a fast return on investment. We are a global company with clients in Europe, America, and Asia. I will get to specifically what we do in a minute. Don't worry. But we are a global company. As I said, we started in 2007, and we have now 60, actually I think we're approaching 65 employees. This slide's a few months old. And we've also very recently opened an additional 5th office in Germany. So we're headquartered in Switzerland. We've got an Edina office 25 minutes south of here. And we've got Singapore and Japan and Germany as well. So Asyril is a flexible feeding company. We make these feeders that vibrate parts around for pick and place. And we actually started in 2007 with a big Delta robot, which slowly moved into a smaller Delta robot. And then we made this in 2011 sell for palletizing with our ASYCUBE and a Delta robot in like a little package cell. But as we started to grow and to realize where our fit in the market was, we decided not to compete with these super precise small robot companies like Mechatronic and to start just focusing on the flexible feeding because we really had a niche product there. We have a patent actually on our 3-axis vibration technology. And so we decided to really focus in on that and kind of stop producing robots. So now we're a complete flexible feeding company and control system that we add as well. So moving on through the ages here to speed it up, we opened up this center in Edina, which I am now the manager of, and Connor is one of our application engineers. And that was in 2019. I started in just at the very beginning of 2020, so I've been here for 3 years. And we, at that moment, introduced our control system for ASYCUBE, which we call I+. Then moving on through the ages again, we opened up a couple more offices in Japan, Singapore, and now in Germany. And very recently we became acquired by a company in Germany called Capitan because they want to help us grow even faster. When I started 3 years ago, we were 30 people and we're already almost to mid-60s. So, what is flexible feeding and what's the problem in the production? Well, you have to get parts from bulk typically and spread them out into singulated fashion so that a robot can pick in place and automate the parts. So the problem really is that most traditional solutions are either highly customized, expensive, prone to jamming, or typically will only work with one part or a very small group of very similar parts. And our solution is to have an effective feeding system that is flexible, evolutive, and easy to integrate. We want to be able to run all of your parts maybe with one machine. So I'm going to give you a quick summary video here of what we're about to go over in the next 30 to 40 minutes, but this will kind of sum it up for you. actually, I'm curious, how many people in here have never even heard of flexible feeding in general? So you're all pretty, two? Okay, but most of you are pretty familiar. What about Asyril specifically? Anybody not heard of Asyril? Oh, cool. So I'm talking to a bunch of experts here. Well, our technology, the one on the far right, which we call flexible feeding, is kind of complementary but a little bit competitive to these other technologies. Traditionally, bowl feeding is always kind of the tried and true method. It's high speed. You can design a bowl to spin up just about any part, but they're not flexible. They're really designed for one specific part, and you can't really do super tiny parts. So they're also prone to jams. They require like really specific craftsmen to kind of fix. So from there, there's also conveyor belt tracking, which are a little bit slower than bowl feeders, but they're also quite flexible, but they're large footprints, a bit complex and higher cost. You have 3D bin picking technologies, which are cool, but I think they're not just quite there yet. They're much slower speed, and they can't pick every part from the bin usually, but they are highly flexible and can handle very large parts. In our solution, we're trying to be as adaptive as possible and pick as many parts while being as fast as we can, but flexible feeding is probably the only thing that you wouldn't compare it to with the rest of it. It can't be quite as fast because you have to wait for the parts to vibrate around, settle down, and then the robot to pick and place them. But assuming you have a part that's small enough compared to the ASYCUBE size and they orient well, you can pick and place typically up to 60 parts per minute, which is fast enough for most applications. So some industries, Asyril being a Swiss company, of course started in the watch industry. That's kind of where we got real big with tiny watch parts and assembling parts for companies like Rolex, for example. And then branching out to the US, we really started to build our med device market share because Minneapolis is the hub for that. And then of course we do tons of stuff in electronics and semiconductors, and now even branching into some larger parts in automotive. So, in summary, Asyril makes two really products. Our 5 ASYCUBE series, our feeders, and our I+ smart control system, which is designed to be the partner with an ASYCUBE. And Connor will talk about I+ here in a minute. I'll just go into a little bit more depth about what ASYCUBes can really do for you first. So ASYCUBes have this, what we call 3-axis vibration technology, which I'll show you in a minute here, where we can vibrate parts in literally any direction we want, which is unique to us, and we have a patent on that. They're meant for rapid changeover and flexibility, obviously, it's in our name. And they're meant to be really easy to integrate. So from our 5 sizes, we can handle parts anywhere from about 1/10 of a millimeter to about 6 inches. So it is a small part in general automation technology. Here's an example slide of all these different parts that could be run with an ASYCUBE 240. So maybe a couple of them will require a different platform changeover, but these are 28 parts, if I'm counting correctly. That would require 28 bowl feeders. And you could do this with one ASYCUBE and probably 4 platforms. So major, major cost savings. So here's what I mean by this 3-axis vibration that we have a patent on. We can move the parts in any direction across the feeder that we want. And you can either do that with or without feedback. Connor will talk about that in a little bit, but our vision system can actually detect where the parts are and bring them away from that edge. So if they're really clumping in this corner, it brings it back to the middle. And why is that important? Well, if you don't have parts piling up in the corner and you're evenly spreading them across the whole platform every time, you're maximizing your chance for them being pickable, and ultimately you're maximizing your chance for a high cycle rate. So here's one more video kind of really highlighting that. So you're going to see this robot come pick and place the parts, but then you're going to see someone just manually push the parts off to the corner, and the camera will recognize, oh, they're in that corner, I need to bring them back to the middle. And this is all happening automatically. And adding that kind of control manually with other vision systems is a bit more in depth. So this is kind of how we make flexible feeding also very easy. So ASYCUBE also lets you detect parts with high precision. Each ASYCUBE comes with an integrated backlight, and we also have optional front lights that we sell in case a part really requires some additional lighting. But you can have many different colors of backlights for precise part detection. ASYCUBE also lets you orient almost any part, as I said. So here's a couple examples of our custom platforms. We can even get super custom with these like 3D pockets and have like a real specific geometry to orient a weird part. But any of the flat, anti-roll, anti-stick Black platforms, they're all standard, and we keep stock of everything, so we have really fast lead times. And if you need something custom like holes or grooves or 3D pockets, we're happy to design that and work with you to make it. So here's some examples of custom plates and how they work. Why do you need an anti-roll plate? Well, if you're going to vibrate these screws around and they're spinning around for 5 seconds, you have to wait for them to actually stop moving before the camera can take a picture and tell the robot where the coordinates of each good part is. If you have an anti-roll plate, if you notice the difference on the right, they stabilize in about half a second, and then your camera can take the picture and start pick and placing immediately. And another example of a useful platform is an anti-stick plate, where we have these micro groove to reduce surface friction on the top. So if you have a part like a quarter or a coin like this, we can make the parts move more efficiently. And when you can make parts move faster, you can get them to the middle faster, spread them out faster, and again, increase your cycle rate. ASYCUBE also lets you orient custom parts, like these pins that require a slot to be held by a flange, or these cylinders that need a hole to be oriented vertically. ASYCUBE also helps you reduce changeover time. So we have a super easy way to change over platforms with 4 thumb screws on our larger ASYCUBEs and a simple 1 mechanism plunger for our small ASYCUBEs. We also have this, what we call purge. So it's a platform that you can change out to and connect to the ASYCUBE output, and your I+ recipe can automatically tell you when you're ready to purge, or you can have a set program time of you running for 4 hours and then you switch to your next batch. So you could have all your parts purged out, even of the hopper and the ASYCUBE, and an operator can dump in your next connector, click a button that runs your next fuse recipe or whatever it is, and you're on your way in less than 30 seconds. ASYCUBE also lets you very intuitively configure it. Our kind of goal and mission at Asyril is to make feeding simple for any user, so you don't need to contact support for your integrator or your distributor. You can really configure stuff pretty easily on your own. So we're trying to change the game in software interface, and we're trying to make it as user-friendly and as intuitive as possible. So this is the software that you get with an ASYCUBE. You actually load it up, and you can configure what we call like the tuning parameters. There's a laser on here. So these tuning parameters, you can configure the amplitude of an ASYCUBE, the frequency at which they vibrate, and the duration. And these are important because you can imagine a really heavy part or set of parts on an ASYCUBE would behave a lot differently than a bunch of really light parts. So they require different frequencies in order to have them like behave at their resonance and actually travel across the platform. So you can do live tuning, where you just set the thing to vibrate continuously, and then you adjust these tuning bars until the parts are moving really well. And you can tune an ASYCUBE with no experience probably very well in under half an hour. Inside ASYCUBE Studio, we try to do everything simple, like I said, so we have wizards to kind of guide you through how to set it up if you've never used the software before. And we have real-time response to the vibration parameters, as I just mentioned. We have optimized hopper management and smart centering. What I mean by this is we can actually have, we can partner with third-party vision systems to have 2 parameter inputs where they would send us like the quantity of parts. So by us, I mean the ASYCUBE. You would send the quantity of parts over and say, oh, well, I've got 7 parts left on the platform, but you told me that 50 was the optimal amount. So I'm very underfilled, so I need to send a longer hopper vibration command to refill. The idea is you're always keeping an optimal fill level on the ASYCUBE. So we can do that with third-party visions, and we can also do smart centering. We also have a parameter where you can send the center of mass from your Cognex camera or something, and then you can get that information and use that as a trigger to say which direction does the ASYCUBE need to vibrate to bring the parts back into the middle. It does get a little bit involved, and Connor will talk about it in a second, how I+, our control system, makes this literally automatic. So the idea is that there's no experience required to use an ASYCUBE. I do have a video showing a recipe creation, but I think that's maybe a little not necessary unless anybody really wants to see it. No, we'll just stay high level, I think, so we'll skip over that. And the last couple slides I have for you are that ASYCUBE lets you save programming time. So ASYCUBEs speak TCP/IP natively, but you can also speak Modbus and I/O for some of the larger 3 ASYCUBes. We also have additional pre-configured gateways which allow you to speak Ethernet IP, EtherCAT, Profinet, and CSIN. ASYCUBE also helps you save programming time with our plugins. So we have plugins for every major robot brand, and we're also compatible with others, but we actually developed some plugins to have like drag and drop commands to make the ASYCUBE control even easier with inside these. So here's a couple example teach pendants from different robot brands. So that's flexible feeding in a nutshell, and our ASYCUBE family in a nutshell. I'll take questions about those at the end. I'm going to let Connor continue on with our I+ product, and then we'll go from there. Thank you.
As Josh said, I'm Connor. I might not project as well, but I'll do my best so everybody can hear me. I'm going to go over our I+ smart control system. It's a vision control system that Asyril has developed to work in tandem with the ASYCUBEs, like Josh has said before. We put a large emphasis on ease of use, a large emphasis on compatibility and configurability. So what is I+? I+ Smart Control commands the hopper, it commands the ASYCUBE, it commands the camera, and it also has some easy setup wizards for calibration of the robot and the vision system. The nice part about I+ is when using the system, you do not need to communicate to both your vision system and the ASYCUBE system. You just communicate to a single I+ controller, and that'll manage everything on the ASYCUBE and keeping your lines of communication as easy as possible. What's in the box? The I+ system comes with a camera and a lens. We use predetermined lens and camera configurations, so you don't have to look too hard on which lens and configurations may be required for your application. We have a set quantity that we found to work best with, let's say 95% of parts. In specific applications, we do have tools that enable you to accommodate other parts possibly, like mirrors and whatnot, but those could be discussed independently. It comes with the controller, a power cable, a calibration plate, as you can see on the bottom right, and it's accessible through via IP through any web browser. So as long as you have a computer, you don't need internet connection, you can operate on I+'s network and connect to it via its IP with an Ethernet cable. We like to think that I+ is a fun, out-of-the-box experience. As plenty of you are probably aware, industrial vision, part picking in general can be kind of a complex problem to solve. There's definitely more complex solutions as well, like line tracking or possibly pin picking. So we like to do the best that we can to ensure that I+ is easy to use. So there's no previous vision experience required. It's easily integrated, speaks TCP IP, Ethernet IP, EtherCAT. We have hardware items that can be included to communicate Ethernet IP and EtherCAT. Natively speaks TCP IP. It's a direct cable connection. All the cables come within the kit. It's accessible with any browser, like I said before. It's in advanced solutions, dual feeding and multi-model, which I'll go over later. It's a one-time perpetual license, so you don't have continuous licensing fees to pay. I+ is not a licensed software. It comes with the controller. Once you purchase the controller, you get the benefits of I+. There's no third-party software or hardware required if you do not need it. And then, like I said, working distances. Like I said, we put a large emphasis on ease of use, and by doing so, we have built-in camera calibration wizard to calibrate the camera to the ASYCUBE plate. We have a built-in robot calibration wizard, and we have a wizard for recipe creation that helps you or walks you through the vision teaching and ensures that you have a solid result that you can depend on at the end. And it's rather quick. Typically, it takes me less than 15 minutes to build a recipe. If you're a beginner user, maybe 30-45 minutes. But if you know what you're looking for on the specific parts, which geometries are important, that'll typically take not much time at all. I'm just going to show a quick video of what a camera calibration procedure looks like. I believe it's about 3 minutes long, so yeah, this is our setup wizard like I discussed. As you can see, 9 easy steps. Set everything up and the system will configure itself quickly. Each of our lenses comes with a recommended starting aperture. Obviously, each application might vary, but we have good starting points for each for adjusting your aperture. And your focus is a little bit more obvious next steps, but an extremely precise application, sometimes it works best to focus on a specific object instead of trying to set your focus on the grid pattern itself. Let's say a very small font, something along those lines. So as you can see, that's a pretty quick process, a really easy to use wizard. Makes it more or less painless, fun experience. This is our, there we go. This is a robot calibration procedure. Similar wizard setup, steps through, as you'll see, I believe, 6 steps, and this helps you calibrate your robot arm to the ASYCUBE to ensure that your pick and place accuracy is consistent. This video is a little bit longer, so hunker down. Quite skip through it. A little bit of it. Basically, what's going to happen in the video is to calibrate your robotic arm to the ASYCUBE. You'll need to place a part in each corner. The robotic arm you'll record your robotic coordinates into the wizard, and then you'll move the arm out of the field of view. You'll take an image of your calibration part on the platform. Once you've taken the image of the calibration part on the platform, it'll marry the robotic coordinates to the ASYCUBE coordinates that it's picked up when it's taken the picture. And it'll marry those together. You'll do that in each corner, and then it'll give you a accuracy at the end. So you'll know if it's going to be consistent enough for your application. So to save you guys some time, I'll let you see what the robotic arm placement looks like on the first position, and then I'll jump to the next one. This is also a process within I+ that can be completely automated. We have tools within I+ that allow you to send the robot coordinates in autonomously, so you can have the robot calibrate itself. Typically, this is what we'll do in a production application if you have to calibrate before production every day or calibrate on part changeovers, things like that. So it makes it easy to use, easy to do. Simple as sending a start calibration command. Finally, our recipe creation wizard. This takes a little bit longer, and I didn't feel like making you sit through a video of that. But if anybody's interested, Josh and I will be out on the floor after this, and we can show you what that would look like. Rather quick process. 7 quick steps for starting up. The second step is setting a size limit around your parts. You need to tell the system how big your parts are, more or less, based on their area. It's going to use that as the first filter. Third step is candidate selection. This is actually an AI teaching step where it's picking up on surface finish differences between each part on the platform, and you as the user will teach it what a good part is by sorting through a handful of images, sorting the good ones into a column on the right and the bad ones into the column on the left. You swipe left for the bad ones, swipe right for the good ones. And then the fourth step is pick point teaching. This is assigning a pick point, a general region where you're going to want to pick the point your parts from. You're going to want to highlight important features for this step that pertain to your robotic pick. So if you're using a vacuum gripper, it's going to look different than if you're using a finger gripper type of situation. For pick angle teaching, this is assigning a pick angle to the part, so each part is going to be picked at a known angle, and then can be placed accurately after. Picking conditions is setting boundaries for your robot so it knows not to collide with the platform and not to collide with other parts on the platform when it's going to pick parts. So you'll set a boundary around it. You'll set a gripper size. Typically, you'll try to make it look as similar to your gripper as possible. You'll set the size, and that'll ensure that the robot will never attempt to pick a part that may cause a collision. And you'll also set a boundary along the outsides of the ASYCUBE to ensure that the gripper will never cause a collision with the frame of the system as well. And finally, like Josh showed before, you'll go through the tuning and tune the ASYCUBE just like you tune on ASYCUBE Studio or tuning in general to customize for each of your parts. That's a TCP/IP communication tutorial. It's kind of a quick video, but it'll basically show, I'll start the beginning of it. It's going to show us the type of commands that ASYCUBE is working with. So when you use our plugins, these commands are pre-programmed to the system, so you can easily select them and drag them into your code. For systems that we do not have plugins with, it's just as easy, except you need to define these variables. You need to tell it what a get part is. You'll need to tell it where the various other commands that you would use, but for a standard application, all you're going to do is start production with a recipe ID. You're going to your robot's going to tell the system to get me a part, so get part. Once you've told it to get part, it's going to, the system's going to take an image or shake the tray if it needs to. It'll take an image, determine if there's any good parts. There's not, it'll shake it. There are, it'll send those coordinates to your robot to be picked. And then you'll just loop that cycle to continue picking. Another nice tool of I+ is real-time data analytics. So on our production homepage that you can pull up via IP address, you can access the real-time analytics to kind of see what your production run rate is. Good parts per vibration. Good parts per vibration, that'll tell you how many parts are typically turning up good after each vibration interval. The time to first part in milliseconds, this is the time that the vision system takes to locate the first part. It does this rather intelligently. It's going to put an emphasis on the first part to get your robot moving. So it's going to locate the first part as central to the center of the ASYCUBE, and then it's going to loop out kind of like that. As it locates the other parts on the platform. And this kind of gives us the quickest time to part that you can achieve. And then it'll also give you fill percentage to see how consistently the system is keeping the ASYCUBE at its fill rate. Other things as well, like pick rate, things like that. Anything that you may be interested in. A couple of our advanced tools that we offer for I+ specifically are dual feeding. I believe Josh brought it up earlier, but dual feeding is feeding two parts on a separated platform. Like earlier in the video, we saw that rivet application and grab the rivet and grab the head. That's a good application. Dual feeding is going to be a good space saver. Typically, it'll be efficient. You'll have intelligent hopper management to keep both sides of the platform optimally filled. One downfall that you might see with dual feeding is your cycle rate will take a hit as you have a reduced working area. Multi-model is our newest release. It's a good cost reduction in some applications where it fits well. There's less hardware involved. You can feed up to 6 different part types, or pick a single part in multiple orientations is what it's truly designed for, and it's available on all ASYCUBE sizes. And to save you some substantial programming time, obviously if you have a whiz in the lab and they're really good at programming, this might not be the case, but for I+, we offer the following plugins, and then if that's not the case, like I said, integration is very easy. There's a very fixed quantity of commands that you can send, and as long as you can speak TCP IP, Ethernet IP, or EtherCAT, you can communicate with the system. So as an overall summary for Asyril and what we do and our place in the industry, we try to help you guys increase profitability by enabling automated solutions, allowing robots to pick the parts they need in the orientation they need them for assembly. And in certain cases, we make it easier than the competitors. And the return on investment is easy, is quickly seen. The cost of our products is, I would say, middle range for the solutions. But the fact that you can take a small project, turn it into reality, and then duplicate that to get to the cycle time that you need makes it an easy tool to prove out if your process is going to be capable or not. And some nice benefits if you choose Asyril. We do free feasibility testing, so if you have any parts or any applications that you think would be a good fit, we have a lab in Edina that you can send the parts to, and we'll give you a full report on how they perform, the cycle times, and the vision analysis. And we also offer our expertise in flexible feeding. We have Josh and I, as well as a large engineering team that helps figure out how the system could be optimized. We work with you to achieve the target that you need to hit. And we have a lot of industry experts in Switzerland that help us make it possible. And we continue to innovate. We're basically, like Josh said, a relatively small company, 65 current employees, about 45 of which are all engineers. We do a lot of R&D and development in our Swiss facility. We're kind of focused on being more of a R&D development company. So in that fact, we have a lot of brain power to help solve problems and innovate new products. And this is kind of what a free feasibility report would be. This would be our cycle time sheet. So with each report, we're going to send you achievable cycle rates with given robot speeds. So this will kind of give you a quick glimpse of whether or not the system's going to be capable. We want to make it clear to you guys if it's going to be worth your time or not, because if it's not, you need to figure out the next solution quickly. And then we offer free training on I+, free training on ASYCUBE. That's all online. Josh and I are also a support staff in Minneapolis, so if you have any Asyril-related questions, we have some emails. We also have some business cards out there if you're interested. We can hand those out. But you can contact us during regular business hours, and we'll do our best to help you out. Thanks for your attention. Hopefully nobody fell asleep.